Let's talk about the difference between relations and functions. First, we need to talk about ordered pairs. Ordered pairs show inputs and outputs. If we look at these three ordered pairs as an example, the inputs are all of the x values. It's what you plug into the equation. The outputs are all of the y values, what you get out of the equation once you've plugged the x in. A relation pairs inputs with outputs. We represent relations using ordered pairs and mapping diagrams. So let's practice listing what ordered pairs were used if we were to look at a mapping diagram. So remember that our inputs are the x's and the outputs are the y's. And then I'm going to use the arrow that connects an input and output to see which input goes with which output. So I could start with this. The 1 has an arrow that goes to the 3. So that means that I have the ordered pair 1, 3. And then I see that the 2 is paired with the 6. So that's the ordered pair 2, 6. 3 is paired with 9. And 4 is paired with 12. Now let's look at mapping diagram B. Again, my inputs are the x and the outputs are the y's. And I use the arrows to figure out which x goes with which y. So start with 0, it's pointing to 0. So 0, 0 is my first point. And then I have a 2. Now this 2 has 2 arrows. One goes to the 1, one goes to a -2. So that means I need to have 2 points here. First, I need to list 2 with the 1, and then I need to list 2 with the -2. And then last, I have a 4 that goes with a -3. When you're writing your ordered pairs, don't forget to put your parentheses and don't forget your commas. Because without the parentheses, without the commas, you just have a list of numbers or you have a 2-digit number inside of parentheses. Now, a function is a special kind of relation. A function is a relation that pairs each input with exactly one output. So we're going to look at the mapping diagram to determine if we have a function or not. When I look at mapping diagram A, I have one input going to one output. So each of these x values only has one y value. So this is a function. In mapping diagram B, most of the inputs have one output, but if I look at the 0, it looks like 0 is paired with 2 different outputs. 0 goes to a 5 and 0 goes to a 6. And since that input does not have just one single output, this would be not a function. So really, I'm kind of looking at the arrows. I cannot have 2 arrows leaving the inputs, but we don't care if there are 2 arrows going to an output. Now let's try to make a mapping diagram on our own. So again, if I look at my mapping diagrams from the previous examples, we have inputs on the left and then outputs on the right. So I'm going to go ahead and list my inputs. Which are the x's, and then my outputs next to it. My inputs are all of the x values, so I have 0, 4, -2, 4. 0, 4, -2, and I have another 4 here, but I've already written it once here, so I'm not going to rewrite it again. Now, let's write the outputs. I have -2, 3, 5, and 5. -2, 3, 5, and I don't need to write 5 a second time. So now we draw arrows that show what input values go with what output values. So if I look at this first ordered pair, I have 0, -2. So I draw an arrow from 0 to -2. I have 4 paired with a 3. So I draw an arrow from 4 to 3. -2 is paired with 5. So an arrow from -2 to 5. And then 4 is also paired with 5. So I go back to the 4 and I draw another arrow coming from it to the 5. And then if I needed to list if this was a function or not, I would look at these arrows. And this 4 has 2 arrows coming from it. So this would not be a function. Let's look at B. So again, I'm going to start the same way. I'm going to list my inputs and my outputs. So inputs on the left, outputs on the right. Okay, my inputs are my x values. So I have -5, -3, -1, +1. My outputs are the y's, -3, -1, -1 again, -3 again. So I only write them once. Now we draw our arrows. -5 was paired with -3. -3 was paired with -1. -1 was paired with -1. And then 1 was paired with -3. And when I look at, if I needed to determine if this was a function or not, I'm looking at these arrows here. I have 1 coming from every single input, so this would be a function. So let's do one more example that extends this just a little bit. Now here's a graph, and I want you to create a mapping diagram. So from my graph, I see 4 points. So I have this point, which is -3, -3. I have this point here, which is -1, -1. We have 1, 1, and then 3, 3. So a lot of times it's helpful for you to identify what your ordered pairs are before you start your mapping diagram. So now I do my same as before. Here's my inputs and my outputs. My inputs would be -3, -1, 1, and 3. It looks like my outputs are the same, -3, -1, 1, and 3. Draw your arrows. -3 goes to -3, -1 goes to -1, 1 to 1, and 3 to 3. And that's my mapping diagram. This one would be a function. I only have 1 arrow coming from every input, but I don't need to do that yet. It did not ask me for it. It just asked for the mapping diagram. So this would be our answer here. So when you have a graph, list out your ordered pairs real quick, and then create your diagram.